My research group focuses on antibiotics, and we also look to identify new anti-infective strategies and agents. Antibiotics are a pillar of modern medicine. They've kind of come under threat by the bacteria's ability to develop resistance. So it's kind of a continual arms race. Innate immunity is your first line of defense. It has a number of different approaches at its disposal. You have these phagocytic cells that will swallow the bacteria and make a very toxic environment for them and will basically try and digest them. The immune cells dump a bunch of toxic chemicals, and bacteria have evolved ways to circumvent this toxic environment, and those defense mechanisms are really critical for their ability to survive long enough to cause an infection. The strategy to inhibit infection instead of bacterial growth is generally known as antivirulence. So if you inhibit the bacteria's ability to interact with its essential components to cause infection, you really have your agent working like right time, right place, and not beyond it. In terms of antivirulence, we're really focusing just on sensitivity to immune attack. So we try and disable the bacterial defenses to those toxic molecules. We focus on nitric oxide and hydrogen peroxide, which are two reactive molecules used by the innate immune system to attack bacteria. Your immune system provides kind of the sword, and this type of strategy opens the armor that the bacteria have. So we're interested in identifying targets, which are like proteins, that if you impair them, you sensitize the bacteria to nitric oxide or hydrogen peroxide. One of those proteins that we found is CLPP, which is actually a protein that degrades other proteins. So CLPP is the first target we've identified, and now we're scaling this up to look at targets over the entire genome. I think everyone's been touched by someone who suffered from bacterial infection or an antibiotic-resistant infection. Ever since actually like high school, I've really been fascinated with your ability to actually cast things in terms of mathematical equations and be able to actually predict or understand phenomenon better. So I kind of took those two interests and put them together, and this was an excellent project where it really fit what I'm passionate about in two arenas.